Okay, so the new topic is resource utilization, which is chapter number 6. So in this topic, we will talk about the effect of resources on the projects. Can you hear me? And can you also hear the screen, see the screen?
Yes, we can see the screen and hear you clearly.
All right. Uh, so, chapter concepts. So first is the taking resource constraints into account when developing a network diagram. So the second one is determining the resource requirement plan for a project. Then leveling the use of resources within the required time frame of the project, and determining the shortest project schedule with the limited resources available. So these are the main concepts in this topic. Learning outcomes. So learning outcomes are create a network diagram that takes resource constraints into account, prepare a resource requirements plan, explain resource leveling, and discuss resource limited scheduling. Okay, so let's start uh, with this topic. So this topic is about project resource management and project schedule management uh, for the project management body of knowledge. Okay, so in project management body of knowledge, there are certain knowledge areas. So one of these knowledge areas is the two of those knowledge areas are project resource management and the project schedule management. So this topic is related with these two topics. Okay. So we start from the uh, discussion of this topic from the technically constrained planning concept. So what is the technically constrained planning? It is about the serial relationships performed in the project. So those relationships in the uh, project network, which are logically established. So, for example, building the foundation is succeeded by building the frame, whereas the building the frame is succeeded by putting on the roof. So we cannot establish a roof without building a frame, or we cannot build a frame without establish a foundation. So that means we cannot change the sequence of such uh, activities in the project, because these are technically and logically constrained. Okay, so uh, this kind of relationships in the project cannot be changed, whether there are resources available or whether there are no resources available. So for example, if we have the resources available for all of these three activities, so for example, if we consider that the uh, there is a different crew for each activity, all the crews are available, uh, but if the first activity has not been completed, second and the third activities cannot be started. So this is the technical constraint planning. Okay, so related with the serial relationships performed in the given sequence. Next, there are other there are kind of relationships in a project which are related with the resource constraint planning. So in the resource constraint planning, available resources allow for concurrent tasks. Okay, so in those situations, we can change the sequence of the tasks based on the resources. As an example, say if we have different types of painting jobs, okay, in the project. So painting in the living room, painting in the kitchen, painting in the bedroom, etc. So any of these painting jobs can be performed. Okay, so you can perform the painting in the living room first, or then you can perform the painting in the kitchen, or then you can perform the painting in the bedroom. Okay, so or paint in the bedroom can be performed first, and the living room, and then the kitchen, or all three can be performed simultaneously. So if for example, if we need one painter for each location, then means we have three painters. So all three painters can start working at the same time, and then they can complete this task, okay, in parallel. However, this type of relationship uh, can become a serial relationship in a situation when we have only one painter available. So that one painter can work at at a location, and then once the work at that location is completed, that painter will work in the other location, and then from that in the third location. So in the resource constraint planning, those parallel activities, okay, those activities which are occurring simultaneously will become a serial activities. So the equity, in this case, the activity sequence will be based on the resource constraint, resource constraints. So such resource constrained planning occurs due to the limited resource availability in the project. Okay, so it is a very real situation. The resources are always limited in the project. Uh, Seldom a project has a sufficient number of resources, or seldom a project will have extra resources which can be very easily applied on all the tasks. So the consideration for the limitation of the resources in the project is a very likely scenario. So therefore, uh, resource limited planning is considered. It has to be considered, and then uh, schedule for the project must be created considering the limitations of resources. Okay, next we are going to consider some examples. Okay. Okay. So for this example, we will first look at the resource requirements plan for the project. Resource requirement plans. So, what is the resource requirements plan? It illustrates the expected resource used by the time period. And it also indicates the amounts and types of resources needed to perform each activity. Okay, so as an example, the resource requirement plan can be represented by uh, like this. So if in a project there are certain resources named uh, Suzanne, Steam, Andy, Jim. So this resource requirements plan shows that the resource named Susan is required for activities 1, 2, 3, 4, and 8. So suppose if there is this project in which we have several activities, and these activities are named by their IDs 1, 2, 3, 4, 8, 5, 6, 7, 8, 9, 10, up to 13. So out of those, say 13 activities, 5 of those activities are responsible by Susan. And we can see that on these 5 activities, total workday needed are 40. Okay, there, for example, maybe X number of days for activity 1, Y number of day for activity 2, and then Z number of day for activity 3, and then X plus Y plus Z plus the duration on the other 2 activities. That is the number of days needed on the activities for that resource is equal to 40. Okay, it is remember that it is not necessary that the number of days a resource is needed on a project is the same as the duration of the activities. Okay, well, in many cases we take this type of situation. We design the project in such a way that the duration of the activity is also the same as the duration of the resource working on the project. That means the resource is 100% utilized for certain activities. But of course, it is not necessary. Sometimes a resource may be 10% utilized on an activity, or 50% utilized on an activity, or maybe 200% utilized on that activity. In 200% utilized on that activity, it will mean that there will be 2 resources that will be working on that activity. Okay, so 100% utilized on that activity means there will be only one resource working for the full duration of the activity, or 50% utilized for that 50% resource on certain activity will mean that that resource will work half the time for the duration of the activity. Okay, so in this way, then maybe we can see that in this resource requirements plan that the resource may work for like 40 days on that project. And from when to when? So when we schedule the project, so there will be a duration along the project. So on this project, this resource may be needed from the beginning to the end of the 40th day. Similarly, the resource requirements plan for the other 3 resources have been given here. So as we can see over here is that although the project is going to take 128 days, but these 4 resources together are needed for an overall duration of 90 days. So which means that not every resource is 100% assigned on the project. So this is the resource requirements plan. So actually this resource requirements plan does not give us more detailed than this overall summary. So we may need some more details for the resource requirements plan. And in fact, we can very easily establish a resource requirements plan from the project schedule. Okay, so let's see some more details, especially in these figures. In this figure, the example has been taken. If you can see it on your screen, there are three graphs shown. This graph or this figure, which is shown on this left, is showing you a network diagram. Start project. So this is the starting milestone of the project. And then there are actually five activities. First activity is the paint first floor rooms, okay? And then paint the basement rooms. And then paint the bedroom, okay? Then paint stairs and hall, and paint the bathroom. So all five painting jobs, okay? And their resource requirements and the number of days for each activity are shown over here. So for this project, we will assume that we have the technical constraint. And the technical constraint is that we can only perform the painting in the stairs and halls after the painting in the uh, first floor rooms. Okay, and similarly, the painting in the bathroom can be only performed after the painting in the uh, first floor rooms. So this is well. Those of you who may be familiar with this kind of projects may argue that why is that? Why not we can, why is there a technical constraint between these? Uh, Maybe you can also think that I think there should not be a technical constraint between the painting stair hall and the painting the first floor rooms. Uh, well, you may be correct, but let's assume for this example, okay? So as it is given. So therefore, we have to follow this sequence. So painting first floor room and then the paintings. Then after that, it will be succeeded by these two activities, painting the bathroom and the painting the stair and halls. Okay, so this is the technical sequence. Okay, this is a technical constraint or logical sequence. So this cannot be uh, violated in this project. Okay, so this is a assumption for this example. On the other hand, painting in the basement and painting in the bedroom can be performed simultaneously with the painting in the first floor rooms. Okay, so there is no technical constraint considered in this project. Okay, in this case. And here we can see that if, for example, if we have two painters needed for the first floor rooms, and if we have one painter needed in the basement rooms, and then if we have this one painter needed for the bedroom, then we can start the work in all these three activities simultaneously. Okay. So in this case, we can see that the paint first floor room has been uh, uh, scheduled for 8 days. So here you can see that in this chart, this is the schedule chart. This activity has been scheduled for the 8 days. So first, second, third, fourth, up to eighth day. So up to the eighth day, this activity, first floor room, has been started. And after 8 days, then the paint, stair, and hall. So paint, stair, and hall activity will take next 4 days. So 8 days plus 4 days. So this is one path on in this project. 8 plus 4 is 12. And then incidentally, this is the longest path in the network. And the second path is the 8 plus 2, that is 10. So 8 here and then 2, which is the bathroom, that is 10. So the critical path is the painting in the first floor and the painting in the stair and hall. Okay, so this is the critical path. So the other paths are, so for example, this is painting in the basement room and the painting in the bedroom. These are the paths, just considering only one activity. So a very simple example for the illustration purpose. So all these activities over here in this schedule have been scheduled at their earliest start time. Okay. So in this case, we can see that although we can start this activity at the basement room uh, at the beginning, but we can even delay this activity to start late as well, because there is no other activity until the end of the project which is succeeding from that activity. Similarly, bedroom activity can be delayed for a few number of days. So based on this information, can you tell me that what is the total slack available in the basement room? So my question is, what is the total slack available in the basement room?
It's 4 days, right?
It is 4 days is the duration of the activity for the basement room. And then after that, there are how many days which we can delay this activity? That will be uh,
8 days.
yeah,
Will of
yes,
8, yeah, 8.
8 days, yes. That will be 8 days. Okay, so it means that the slack available in the basement room is 8 days. And by this, then you can say that the slack available in the paint bedroom is
6.
6 days. Okay, so 6 days. And then paint bathroom, the slack is,
2 days.
yes, it will be 2 days. Okay. So in this case, now we have scheduled these activities for their early start time. So now we know that we need two painters for this paint first floor activities, and we need one painter on the basement room and one painter we need in the bedroom. So, and then we have over here, there is a timeline over here. So timeline starts from 1, 2, 3 up to 12. And then we can use this kind of graphical representation for the activities to add up their resources for each day. Okay, so you can see that for the first that means uh, for this activity, first floor rooms, two painters are needed. It means that two painters are needed on day 1, two painters are needed in day 2, and then the same two painters will work for the all the remaining days in the activities, and similarly for other activities. So it means that if we are going to start these three activities, that is the first floor rooms, basement rooms, and the bedrooms at the same time, we will need 2 plus 1 plus 1, that is total 4 painters on day 1. Okay, and then 4 on day 2, 4 on day 3, and 4 on day 4. But starting from day 5, we will need 3 painters only, because by this time painting in the basement rooms have been completed. Okay, so we will need 2 painters on the first floor room and the 1 painters on the bedroom only. So we will need 3 painters. And then for the next day, 3 painters. So similarly, we can just add up these duration of the requirements of the activities, the requirements of the resources for each activities. So starting from the day 7, we will need 2, 2, 2, and up to uh, day 8. And in day 8, uh, uh, starting from the day 9, activity in the first floor room has been completed. And then we need resources on the stair hall and the bathroom. So 1 plus 1, 2, and then 2 and 2. And then for the last day, we need 1 and 1. So you can see that we have started with the 4 painters in the beginning of the project. And then along the duration of the project, the requirements for the painters decreased from 4 to 1. So in this case, you can see that 4, then 3, then 2, and then 1. And okay, so this is the resource utilization for painters on this project. So this resource utilization for painters on this project is the requirement on this project. So this type of resource utilization is very typical for those projects in which all the activities are started at their earliest start time. So in this case, as you see that we have scheduled all the activities at their earliest start time, okay? And therefore we have achieved this kind of resource utilization. In which, what is this kind of resource utilization? In this, you can see that the requirements of the resources is fluctuating, okay? That means it is not constant. It is changing along the duration of the project. Okay. So if in this case, if we would like to have the requirements of the resources for the project in such a way where we can reduce this fluctuation, then it will be much better. It will be much better for this project. The reason is because for the fluctuating of the resources, then it may be sometimes difficult to hire the resources. So for example, for the first day, we will need 4 painters. And then starting from the 5th day, we will need to remove 1 painter from the job. And then later on, we will need to remove 1 more painter from the job. And then later on, we will need to remove 1 more painter from the job. So this type of hiring and firing of the resources from the project will have a bad impact on the project and on the morale of the project. So therefore, for more ideal situations, we would like to have the resources which may be utilized more uniformly on the project. So although in this case, sometimes although in this case we have seen that the resources have been used in a decreasing order. For some other projects, we may have that we may be using less resources in the beginning, and then more resources in the middle, and then less resources again, and then more resources again. So that will be clearly a more fluctuating use of the resources. So when there will be a fluctuating use of the resources, then sometimes we need to hire the resources. Sometimes we need to fire some of the resources. So this hiring or firing of the resources is, I'm actually repeating, this hiring or firing of the resources is not good for the proper resource management of the project. Because sometimes when you hire the project, the resources midway between the project, then that resource may also need to learn the task for the project, and then it will take some more time for that resource to do that task. So therefore, in this in projects, it is needed to have a more smoothed out resource utilization plan. Okay, so a more smoothed out resource utilization plan should be achieved. And this type of smoothing of the resource utilization plan is called as the resource leveling. Okay, so this resource leveling is actually the minimization of the resource requirement fluctuations. That means these fluctuations needs to be reduced, and later on we will see that how we can reduce those fluctuations. Resources are applied as uniformly as possible. So when we can reduce the fluctuations, of course, the resources will become more uniform on the project. And this resource leveling attempts to keep the project schedule within the required time. So the first priority in the resource leveling is that we do not change the overall schedule of the project. That means the project is not, the completion date of the project is not changed or not delayed uh, by this change of resources. So we will see that how is it possible, and also we will also see that sometimes it is also not possible. Uh, Delay the start of the non-critical activities. So this is achieved by delaying the start of the non-critical activities. So this is where the use of the Slack comes into the picture. Okay. So not only the critical activities are important, but the non-critical activities are also important, because the non-critical activities we can use for the resource leveling. And of course, use the positive slack. So for this purpose, the positive slack available in certain activities is to be used. And for this kind of project, for a simple task, for a simple project such as this, the one we are considering in this case, like painting, so we can do it very easily. And then we are doing it for our own understanding as well. However, for more complicated situations, when there are several activities and several resources working on certain activities, then the project management information systems, such as the Microsoft project software, can assist us to do this task. And if delayed beyond the slack on critical path, project will be delayed beyond the required completion time. So, this last step over here means that sometimes it is not 100% possible to completely level the resources without delaying the duration of the project. Okay, so in those situations, the resources are very much limited on the project, and then the delay on the activities of the projects are inevitable. Okay, so let's see it with the help of the example. But that situation, when the changes in the resources for the projects are inevitable. This type of situation is called as the resource limited scheduling. Okay, so remember that resource leveling and then the resource limited scheduling. So in the resource limited scheduling, our objective in those situations is that we should allow the minimum number of we should allow the minimum amount of delay in the project, because the delay is inevitable, but our priority should be that whatever the delay which is happening, that should happen in a minimum possible time, in a minimum possible change. So in the resource limited scheduling, we have the limited number of resources. We cannot simply provide the more resources. So for example, if we need 4 painters on a certain day on the project on 3 different activities, but we only have 2 painters available to work on the project. So then, of course, we have no other choice rather than to work with those 2 painters on the project. And then those parallel activities will become the activities in a serial. That means first one activity will be performed, and then when the task on that activity will be completed, then the activity work will be performed on the other 2 activities, one after the other. So this will, in some of the cases, will extend the project completion time if necessary. Okay. In the resource limited scheduling, and then it will give the activities with the least slack the first priority to be scheduled, and it will delay the lower priority activities. So this can be shown with the help of the examples. Okay, so just like in this case, if you have resources available over here, in this case, paint living room, paint kitchen, paint bedroom, and then if we have the resources, if you don't have the resources available, these activities can be performed in parallel. But if we don't have the resources available for all of the 3 activities, then these activities can be performed in a sequence as well. So the other is the one case is the available resources allow for the concurrent tasks, and the other case is the limited resource availability forces us to perform the tasks in series. Just a moment. Yeah, hello. Okay, so as an example, just look at this chart. So we have considered this chart for this project, and then we have seen that 4 resources are needed, and then 3, and then 2, and then 1. So we have already discussed this chart. But let's look at the resource leveling, and then we can see that how to level the painting, this painting project. Okay, so 4, 3, 2, 1, 1, and then this is the resource limited scheduling, and then this example starts from here. Okay, so suppose that there is a limit of two resources in this case. Right, so yeah, over here. So suppose that there is a limit of two painters in this case. So this is the original plan, okay? And now in this case, we need four painters in the beginning. So, and but we only have two painters available. So how we can tackle this situation? So in order to tackle this situation in rather a more systematic way, okay, what I think in the big, this is a very simple project. So if you just look at without much thought, you can see that since we only have two painters available and but we have a requirement of four painters. So, and then we can see that over here we need two painters for this first floor rooms, and we need one painter for the basement room, one painter for the bedroom. So what we can do is we can start this first floor room task, and then we can delay these two tasks. Okay, so in this case, in this way, we will these two painters which will have, we can utilize it. So therefore, instead of showing these tasks here, then maybe we can delay it to start later. Okay, so in this case, that 4 will become 2, like that. However, this we can do it, but let's do it in a more systematic way. And the systematic way to do this will be to consider the slacks in those tasks. So so for illustration purpose, the amount of slack in each of these activities has been shown over here. So 0, 0, 2, 8, and 6. Okay. So these first two activities has the slack of 0, and the uh, other activities have the slack of 2, 8, and 6, as we have determined before. Okay. So when the resources are limited, then the general rule for scheduling the activities is that we give first priority. We give first priority to those activities with the minimum slack. Okay. So in this case, the activities with the minimum slack are the first floor rooms and the stairs and hall. So, and then we start from the beginning of the project. So we take this, we take the beginning of this project. That means the day one. So in the day one, we have three activities over here. Okay. So we will not consider this stair and hall at this time because the stair and hall has been scheduled to plan, scheduled to start on day 9. So we only consider this, we start from the beginning, okay, from the day one. So in the day one, okay, remember that I'm talking about the systematic way of solving this problem. So in the systematic way of solving this problem, we will start from day one, then we will move to day 2, day 3, day 4, like that. So in day one, so we have this activity, first floor room and basement room and bedroom. So out of these three activities, the minimum slack is for the first floor room. Okay. So this activity will have the first priority because it has its slack is 0 and the slacks for the other two activities are 8 and 6. So definitely this activity will have the first priority. And what is the meaning of the first priority? The meaning of the first priority is that that activity which will have the priority will be scheduled first. That means the work on that activity will be performed first. So it means that in this case, we will start the work on this activity, first floor rooms, And it is an assumption in this project. We can make an assumption that once we start the work on that activity, we will work continuously on that activity until that activity is completed. Okay. So since we have two painters available, those two painters will work in those activities continuously until that activity will be completed. So by this, what will happen is that because only two painters are activities and no other activity can be started. Okay, so this means that this painting in the basement room and the painting in the bedroom cannot be started. So this means that these two activities will move from here to here. So for example, basement of the room will now instead of starting in and the first day will now start on the day 9. Okay, and then we'll finish on day 12 in this case. Okay, so now but with this change, now let me see what is going to happen. So what happens? So with this change, now you can see that the slack in this basement room has now reduced to 0, because earlier the slack in this basement room was 8. Okay, but now the slack in this basement room is 0 because we delayed it by 8 days. We delayed it by 8 days. So its slack has reduced from +8 to 0. So +8 if now there is a delay in this activity, and then its slack has been now reduced to 8 days to 0. Okay, so here you can see that 0 days. And now the slack in this bedroom activity has become -2. Why? Because you see that previously the slack in this was 6 days, and then we delayed it by 8 days. So 6 minus 8 is -2. Okay. So here you can see that there is a slack of -2 days. Okay. Remember that when we have this negative slack over here, the duration of the project has also extended by 2 days over here. The duration of the project has been also extended by 2 days over here. Okay, so originally the duration of the project was 12 days, 8 plus 4, that is 12 days, but now the duration of the project is 14 days. Okay, so now this is the situation. There is no change for the bathroom of one paint activity. Okay, so in this way, now we have moved from day 1 to day 9. Okay, so now we have to consider the day 9 in this case. So in day 9, now we have 1, 2, 3, 4 activities. 4 activities over here. And out of these 4 activities, the activity with the bedroom has a minimum slack of -2. Okay, so the minimum slack is -2. So therefore, by our rule, this bedroom activity will be given a priority. Okay, so this will be scheduled first. So we will use one painter in this activity. And we still have one more painter in this case because there are 2 painters available. And then in that situation, the other painter will be used in one of these 3 remaining activities. So out of these 3 remaining activities, now we have stair and hall and the basement room as the 2 activities with the minimum slack. So 0 day and 0 day. So both have the same slack. A bathroom has a slack of 2 days. So this does not have the priority. But stair and hall and the basement room both has the same slack. So, but we can only apply a painter in either one of these activities. So we have to choose from either stair and hall or the basement floor. So then in that case, which activity we will choose? Okay, so as a rule, maybe we can say that we will choose that activity which will have the smallest duration. So, but in this situation, we can see that both activities have the equal duration, which is 4 number of days. So these two activities, stair and hall and the basement, are equal in these two priorities. So if these two priorities are equal, then the third priority will be that we will choose that activity which will be which will have the lowest ID into that project. What does it mean? Although we have not shown any IDs for that project, but most likely that this activity has an ID of 1, this activity has an ID of 2, 3, 4, like that. That means which that activity which comes earlier in the serial list of that project. So we then therefore we can decide that we will schedule this stair and hall activity. Okay, so at this point we will then bedroom and then stair and hall, these activities will schedule, and then we will delay uh, this basement room and then the bathroom. Okay, so since we have a slack of 0, that means this activity will be delayed by some number of days, and then this means bathroom activity will be delayed by some number of days. So therefore the resource requirements will become 2 and 2 in this case. So but in any case we have to delay these activities by, say, at least 4 days, because this activity has been scheduled. This activity has been scheduled, and then we can delay this project, the other two activities as well. So in this case, what we can see over here is that now, since we have fixed these bedroom and the stair and hall, these activities, the delay in the activities of the bathroom and the basement floor has happened. So we have further delayed this basement room activity by 4 days. Remember that previously its slack was 0, but now its slack is -4. So we have delayed it by further 4 days. So that means instead of starting at day 9, it is now starting at day 13. Okay, so its slack has been further reduced to 4 days. Okay, and then for the bathroom and painter, then it has been delayed by also 4 days. Earlier its slack was 2, but now its slack is -2. Okay, so it has been also delayed by 4 days. So in this way, like now we can see that we have 2, 2, 2. Okay, that is the we are meeting the requirement for the project up to the day 12. But the project has already been delayed by 4 days in this case. So in the day 13, now we can see that we have now this situation. So earlier we have already fixed this bedroom activity, so this we cannot change. So out of these two activities, the basement room activities and the bathroom activities have out of this bathroom and the basement room, this basement room has the lowest slack. Okay, so therefore in this case this basement room activity will be scheduled over here. That means we will not change, and then we will change the bathroom one painter activity by a further 2 days. So that means from here it will become as further 2 days delay over here. So in this case, then one of the painter over allocation over allocation will be removed from here, and then this 3 will become 2, and then there will be 2 and 2 over here. So as a last revision, then this bathroom activity will be changed from day 13 to start at day 15. So in this case, you can see that this bathroom 1 painter, the slack will change from -2 to -4. And now we can see that in all the number of days for all the 16 days of the project, there will be a maximum requirement for the painter as 2 days. And then we have, in this way, we can then schedule the project. And this type of schedule of the project is meeting our requirement. And the requirements are forced by the limitation of the resources. That is the 2 painters in the project. Okay, but by doing this, we can see that there is a delay in the project, and then that delay in the project is evident from the the lowest amount of slack available in the projects for 3 of those activities. For the basement rooms and for the bathroom, there's this lowest slack of -4. Okay. So the project has been delayed, but the requirements of the resources have been met. There is no other choice in this case. So in this resource limited schedule. So therefore, in this way, the resource limited schedules are scheduled. So remember that when doing these changes, I have mentioned about the rules. Okay, the rules for the scheduling in a resource limited scheduling are that. So first of all, we will schedule those activities. That means we don't change or those activities which have the minimum slack. Okay, if there are 2 or more activities having the same amount of the minimum slack, we will choose that activity with the smallest duration. If there are still 2 or more activities having the same smallest duration, we will choose that activity which will have the lowest serial number into this in this project. So by following these 3 simple rules, then we can move the activities, we can schedule the activities into the project, and this will most likely give us a near optimal result for the minimum possible delay in the project, and that is for the resource limited schedules. Okay, so we have looked at the resource limited schedule, and then there is another situation which we should have, which I should have described before, that is called as the resource leveled schedule. In the resource leveled schedule, incidentally, we will have enough number of resources available. We can still move some of the activities in the resource leveled in that type of schedule, but we may be able to level the schedule. That means we can make this scheduling, we can make the resource utilization more or less uniform without delaying the project. So the changes into the schedule will be performed in more or less the same way as it was done for the resource limited schedule. Yes, so do you have any question up to now? So the difference between what is that, for example, you should be able to understand the difference between the resource level schedule and the resource limited schedule. So do you have any question about this?
No questions.
Professor, can you hear me?
Yes.
I have a question. In which program always manipulation with resource allocation and creation of such graphs we can perform? Which software?
Yeah, so you can, well, if you're for a simple case, for the manual case, I think you can perform it in Microsoft Excel. I think maybe I could show it to you, but let me do it in the next lecture. And for Microsoft Excel, of course, we have the option for the resource leveling. So Microsoft project, sorry. Microsoft Excel, in the Microsoft Excel, you can perform it manually. So that I will perform in the next lecture. I will illustrate it. In Microsoft project, for most practical situations, so there are options for the resource leveling. So Microsoft project will provide you two types of resource leveling within the resource constraints or resource leveling outside of the resource constraint. So one is the resource level scheduling, the other is the resource limited scheduling. So we can use Microsoft project. And in Microsoft project, you can apply the resource leveling to some to one activity or to a set of activities or through the whole project as well. So there are various options available in Microsoft project as well. Yeah, perhaps I can keep it for the next lecture. So maybe I will try to illustrate it as well in the next lecture on how to do it on Microsoft Excel as well as on Microsoft project. Okay. Yes. Does this answer your question?
Yes, thanks. Clear enough.
Okay. Okay, so resource requirements for the information systems development. What are the resources? So resources are the people, hardware, software, data, and network resources. And so we are talking about the information systems development project. So for the information systems development project, normally the resources are these. The more accurate the resource assessment, the more likely the project can be completed on time. So it is important to have an accurate assessment of the resources. The most common problem in the resource allocation is the over allocation. By the over allocation, which means that resources assigned to multiple tasks at the same time. That means a resource is needed on more than one task at the same time. So this means that this is a more, this is clearly a conflict for the use of resources. So which should be minimized and which should be eliminated from the project for the better resource management. Project management information systems. So when we talk about the project management information systems, so we talk about the project management software. So using the project management software or the information systems, so we can perform the resource allocation problems in a more convenient way. Okay. So we can create and maintain a list of resources. We can store the availability rate and costs for the resources. We can assign the resources and calculate the cost. We can assign the calendar to record availability, and then there is for resolve over allocations for the best solution. So in the next lecture, I think I will try to illustrate some example on the Microsoft project. In this lecture, I think, actually, I started also late, and then most of the time was spent on the manual explanation for this resource leveling and the resource limited scheduling. Okay, so in this topic, we can learn these critical success factors. So maybe you can go through these critical success factors, and then that is the summary of this project. And then I would like you to read this summary as well. Okay, so that's all for today. So I will continue this topic, that is the software part of this topic in this in the next lecture, and then we will also start the next topic. There will be, of course, a quiz for topic number 5 and 6, but that will be in the next week. Okay, so I will also announce on Moodle as well. Okay, so that's all for today. Anyway, if you have any questions, I am here